Optic Refraction by Michael Salcedo, David Guzman, Savelli Yepes, Mario Contreras, and Alder Fernandez.
Optics is a branch of physics that studies the behavior and properties of light, such as reflections, and the main topic of our demonstration, which is refractions. Simply, refraction is when light passes through two medias and the direction of light changes. The famous Pink Floyd album uses the idea of refraction on their album cover, with light entering the left side of the prism. Once it has entered, the speed of light slows down, bends, and changes direction. The light then refracts more, exiting the prism. Longer wavelengths tend to refract less, while shorter wavelengths tend to refract more. The angle of refraction orders the wavelengths displaying visible light spectrum and a rainbow exiting the right side. The same idea applies to rainbows that appear from rain. The white light from the sun enters the droplet, dispersion happens, the light then gets refracted, exiting the droplet, and the rainbow colors exit. Snell's law is used to calculate the degree of refraction and in relation to the incident ray. This formula is n subscript sin theta subscript 1 equals n subscript 2 sin theta subscript 2. N subscript 1 equals incident ray, n subscript 2 equals refracted ray, sin theta subscript 1 equals incident angle, and sin theta subscript 2 equals refracted angle.
Okay, this is the analysis of our experiment. So we successfully recreated the rainbow. This means that refraction did indeed take place. And obviously, from what we researched, of course, it means that the sun rays went from one medium to another, which was the air to the water droplets. They'd slow down, and they would exit from different angles than what they would originally enter from. The order of the rainbow also shows us something that we researched, which of course is wavelength. The longer the wavelength, the harder it is for that ray to refract, which can be seen with red, as it's on top, so it's refracting less. And towards the bottom, we can see purple and yellow, also blue, which have shorter wavelengths. This allows them to quote-unquote bend more than red, which of course is just refracting. With both of these together, it's obvious that we successfully replicated refraction in our own backyard.